All right, guys. So I'm gonna get us going on this last little bit of main content, which is topic 11.3. We did topics 11.1 and 11.2 way earlier in the year. The measurements and data processing, the uncertainties, the graphing. But we did not do topic 11.3 because this is looking at different methods of analyzing molecules, and specifically organic molecules. So there's really not any point in doing it until after we've done organic chemistry. So there are 4 things that are covered in this section. They are generally going to be in your paper 2 or paper 3 sections, although there are some paper 1 questions that I've seen with index of hydrogen deficiency particularly. So this is the study guide, the topic 11 measurements and data processing study guide, starting around page 7. So we're skipping over the parts, the beginning parts, but feel free to go over those, to review those about measurements and uncertainties and all that kind of stuff. And again, the study guide answer key is also posted up there. I also put up a lot of, in thinking, I opened up a bunch of stuff in thinking as well, and I will do some more of that today. All right, so index of hydrogen deficiency is one way of analyzing the structure of a molecule or something, learning something about the structure of a molecule. And you can use it from a visual structure or from the name of the molecule or just from the molecular formula. And it will tell you something about essentially how unsaturated the molecule is, how many double bonds or ring structures or other things that would keep something from being a straight chain alkane, essentially. What things would be, how many hydrogen H2 molecules would be needed to add to that structure to make it completely saturated. All right, so if you have a lot of double bonds, your index of hydrogen deficiency is going to be higher because it's going to take a lot of hydrogen molecules to saturate that. There is a formula, and I don't really know why they put it as X and Y, because X is just carbons and Y is just hydrogens. So why they didn't just say 2 times carbons plus 2 minus the number of hydrogens, whatever. But this formula you can use with the molecular formula of the compound in order to determine what the degree of hydrogen deficiency is. For example, we have here C6H12. In this case, it's hex 1-ene. This is something that also I don't think I went over sufficiently. It's in the nomenclature packet I gave you and in the key that I already posted for that. But when we talk about alkenes, double bonds, the number that's associated with it tells you which carbon in the longest chain the bond starts with. So obviously any double bond involves 2 carbons. So it's just the number is gonna tell you like the earliest carbon in the chain where the double bond starts. So in this case, it's starting with carbon number 1. Hence hex 1-ene, or you could also write it as 1-hexene. So here's this substance, and we've got 1, 2, 3, 4, 5, 6 carbons, which you can also get directly from the molecular formula. And we've got 12 hydrogens. So if we plug this in, we've got 2 times 6 plus 2 minus 12 divided by 2. So we've got 12 plus 2 minus 12 divided by 2. That's going to give us 2 over 2, which is going to give us 1. And what that's saying is that in order to saturate this molecule, we would need to add 1 H2 molecule. It's going to come in, break this double bond, and add hydrogens to each carbon. So that's 1 H2 molecule, index of hydrogen deficiency is 1. So that's how that works. And again, you can do it straight from the molecular formula. So, and there's an exercise here that you can do on your own and check the answer key for with a triple bond. Triple bond's obviously going to need, each triple bond's going to need 2 hydrogen molecules. Things that you don't count when you are, how to deal with things other than carbons and hydrogens. So sulfur and oxygen, the presence of a sulfur or oxygen doesn't add anything to your formula. Halogens are like hydrogens. So if I'm looking for the IHD for this molecule here, I'm treating this chlorine like a hydrogen. Okay, so I'm adding, so this is just like C2H6, even though one of these is a chlorine. For the purposes of the hydrogen deficiency, it's the same thing as a hydrogen. Okay. If you have a nitrogen, because nitrogen has that lone pair and is only going to form 3 bonds, if you have a nitrogen, then for every nitrogen in your formula, you're going to add 1 carbon and 1 hydrogen, because an NH2 group is equivalent in terms of the saturation to a CH3 group, to a methyl group. All right. There's no double bond here. There's just a lone pair on the nitrogen. The carbon isn't going to have a lone pair. It's going to have 3 hydrogens. So when you're doing the formula version, if there's a nitrogen in your molecular formula, you consider that as 1 carbon and 1 hydrogen on top of what is the carbons and hydrogens that are given in the formula. So if anyone does the IHD for these 3 molecules, you'll see that they're all 0, okay? And that is because they're all saturated. There's no double bonds, there's no cyclical chain, there's no carbonyl group. It's just everything has the right number of hydrogens on it if we assume that this is equivalent to a methyl group. Okay? So if you are looking at a structure and calculating the IHD from that, this is kind of how you add things up. So any single bond does not add anything to the hydrogen deficiency. Double bonds between carbons or carbon and oxygen double bonds are going to add 1 to your IHD. A ring structure is going to add 1, because if you think about it, if you've got, say, a cyclopentane, all right, breaking this bond and turning it into a straight chain would add a hydrogen to each carbon. So you would add 1 H2 to break up that ring. Okay, so double bonds or rings are each going to add 1 hydrogen molecule. So you're adding 1 to your index of hydrogen deficiency. Any triple bonds are going to each add 2. Okay, so this is not in your packet. This is from Question Bank. This is Tylenol. And the question is, what is the index of hydrogen deficiency of Tylenol? So take a minute to calculate that for yourself. Mm-hmm. The paracetamol is the British version of, yeah. Yeah. Yeah, so it's acetaminophen. It's not ibuprofen. That's a different, ibuprofen's a different molecule. So paracetamol is the generic name of, yeah, of that drug. Yeah. This is Tylenol. Ibuprofen is Advil. That's a different molecule. But. Yes, that is the consummate test-taking strategy right there. It's not 1, it's not 2, it's not 7. Right. Yeah. It's not A. Nope. think about what that aromatic ring consists of, okay? It is not B.
Oh, that ring thing is made of like 6 carbons, right? I mean, the ring structure is different. I think. Yeah, that's what I was thinking. Is it a ring structure? I don't know. I think it's C. Oh, she's doing something, guys.
Okay, so that circle means that we have alternating double bonds in the ring. Okay? So each one of those is going to take an H2 to break, right? So that's 1, 2, 3. Oh, H2. What else is going to take an H2 to break up? This one, yep. So that's 4. Anything else?
The nitrogen.
Not the nitrogen. Yeah, great. What is it, Grace, that needs to happen? Yes, the ring also needs to be broken up. The breaking of the ring.
Wait, is the right word? Yeah, that's the word. So there are 2 different things.
So there's the double bonds, and then there's opening up the ring. So the ring itself, outside of the double bonds, is another hydrogen deficiency. So it's C. Yep. Okay. All right. All right. So that's the kind of question that you might see on a paper 1. And it might either give you the molecular formula, or it might give you the name, and you would then have to either for yourself figure out the formula or the structure and kind of draw it for yourself to figure this out, or use the formula. What somebody in first period did was they went through and said, okay, carbon, 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 carbon. This counts as a carbon plus a hydrogen. And then they added up all the carbons and all of the hydrogens and used the formula, and then ended up with 5. Okay. Yeah. So yeah. So either way, looking at the structure, if that's more up your alley. For me, I like to look at the structure and count it up that way. But if you forget about the ring, then messed up. But doing it with the formula also works. Okay. All right. So I am not sorry that that's as far as we're getting today, because we had a great conversation. But this means that we're gonna finish this up tomorrow. I will post videos. Thank you guys for your time.